Okay, think about the last glass of water you drank. Seriously, where did it come from? And I don't just mean the tap. Where has it really been? Today, we're going to trace the incredible ancient story behind every single drop of water on our planet. It is an absolutely epic journey, so let's follow it together.
You know exactly what I'm talking about, right? A big rainstorm comes through, maybe you float a paper boat, and then a few hours later, the puddle is just gone. But where did it go? It doesn't just, poof and disappear, does it?
Well, the simple answer is no, it definitely doesn't vanish. That water is just kicking off the next leg of its constant globe-trotting adventure, a cycle that's been happening for, just billions of years.
And this endless journey? Well, it has a name, and it is absolutely fundamental to all life on Earth. We're talking about the water cycle.
It's this beautiful four-stage process. First up, the sun's energy acts like a giant engine, lifting water into the sky through evaporation. Then, as that vapor rises, it cools down and starts bunching together to form clouds. That's condensation. Once those clouds get so full they can't hold another drop, we get precipitation, rain, snow, you name it. And finally, all that water collects in oceans, rivers, and lakes, all set to start its journey one more time.
Now this leads to a pretty mind-bending idea. Our planet is basically a giant sealed-up terrarium. The amount of water we have is what we've got. It's finite. So the very same water molecules that dinosaurs drank are still with us today. The water in your coffee this morning could have literally been part of the Amazon River at some point. It's wild.
But wait, this brings up a fascinating paradox. If water is always cycling around and our planet is covered in it, why are we always hearing about water scarcity? This is a huge global challenge, and the answer, well, it's all in the details.
So this table tells a pretty shocking story. A whopping 97.3% of all the water on Earth is saline. It's salty ocean water. We can't drink it. That leaves less than 3% of all the water on the entire planet as freshwater. And believe it or not, the story doesn't even end there. Because even that tiny slice of fresh water isn't really available to us. Look at this. Over 77% of it is locked away as ice in glaciers and ice caps. The water we actually use from lakes and rivers, it makes up less than 0.5% of all fresh water. It is an incredibly tiny, precious resource.
So there it is. That's the paradox of our blue planet. We are literally surrounded by water, yet billions of people are struggling to get enough. The problem isn't the total amount of water. It's how much of it is fresh, clean, and in the right place at the right time. Okay, so now let's turn our focus to that enormous 97%, the restless, constantly moving ocean. Because unlike the calm water in a pond, ocean water is never, ever still.
Ocean movements pretty much fall into three main buckets. You've got waves, which is basically the wind's energy moving across the ocean surface. You've got tides, which are like the rhythmic breaths of the ocean, pulled by the moon and the sun. And then you've got currents, these massive rivers flowing inside the ocean itself, shaping our entire planet's climate. Let's just look at tides for a second. Twice a day, the gravitational pull from the moon and sun causes the ocean to literally bulge, creating a high tide. This rhythm is incredibly useful. It helps ships get into harbors and brings fish closer to shore. And then, as the Earth keeps rotating, the water level falls back down, creating the low tide.
But the ocean's movement isn't always so predictable or gentle. Sometimes, its raw power is completely unleashed in one of nature's most destructive events.
And that is a tsunami. The word itself is Japanese for harbor wave, which is a chillingly accurate name because harbors are often just devastated when one strikes. Now, these are not surface waves caused by wind. These are massive displacements of the entire column of water triggered by huge forces like earthquakes deep under the sea.
The 2004 Indian Ocean tsunami is just a devastating modern example. A massive 9.0 magnitude quake actually displaced the ocean floor, sending a wall of water rocketing across the ocean at the speed of a commercial airplane. The impact was just catastrophic. It reshaped coastlines and, tragically, took hundreds of thousands of lives.
And this is the eerie, deceptive warning. One of the first signs of a tsunami is a rapid, completely unnatural withdrawal of water from the coast. It exposes this huge, sudden beachfront where the ocean should be.
Tragically, on that day, many people didn't know the danger and actually went to the shore to see this strange thing happen. They were then met by the returning wall of water, and the result, seen here in places like the Tamil Nadu coast, was just absolute devastation.
And to give you a real sense of the sheer scale we're talking about, the largest tsunami ever measured was 150 meters high. That is as tall as a 50-story skyscraper. The power of water is just immense.
So, from the gentle little rain puddle all the way to a terrifying tsunami, the journey of water really reveals both its life-giving side and its awesome power. And this brings us to our final and, honestly, most important point.
You see, understanding water isn't just a science exercise. It is one of the most pressing issues of our time. From rivers drying up to the challenge of getting safe drinking water to everyone, our very survival is tied directly to how we manage this incredibly precious resource.
At the end of the day, it all comes down to a simple, undeniable truth. Water is absolutely essential for survival. Nothing else can quench our thirst when we're thirsty. There is no substitute.
So we are the current guardians of the very same water that has cycled through our planet for eons. The real question for every single one of us is, how are we going to care for it now, for all the generations to come?